So here's your warm-up for class today. We're working on finding common denominators and comparing fractions. So I want you to compare these fractions. So which one of these is bigger? So find a common denominator, change the numerator, and tell me what you find. Try this one as well. So try those, and let me know what you come up with. What it is that you have to do for question 3. Because a few people are struggling with that. If you're struggling with 1 and 2 as well, that's okay. Because again, fractions are kind of a beast that way that you're going to just get slowly better at if you hate them already. The main focus of today is, can you find the common denominator? As long as you can find the common denominator, you'll be okay. But the next one. Question 3 is asking you to find sums for every row in the square, every column, and every diagonal so that they add up to 1. So it's important you guys can kind of understand what 1 is in this case. So the top corner is 8 over 15. Then we have 1 over 15. Then we have a blank spot. Then we have 1 over 3 here. Now, you're either going to be good at matching up denominators or you're not. But here's the thing I need you to understand. If this whole row is 15ths, this whole row right here, how many 15ths do I need in order for it to equal 1? Layla? 15. I need all of them. I need all 15 15ths. How many 15ths do I have so far?
1.
Go. 9. I have this 8 right here and this 1. That's 9. So how many more would I need? Go. 6. So that's how you go about solving this question. 6 15ths is what I have here. That equals 1. I know I'm good. Now I'm running into trouble though. What is the trouble I'm running into? Because I can either solve this diagonal now, because I have 1 and 2, I can solve the third. Or I can solve this piece here, because I know this one and this one. But what's the issue, Brooke?
Is that we have nothing at the bottom for us to
Sort of, because I only ever need 2 of the 3 to find the third. Like I have 1, 2 to find this third one. But there's something I can't inherently do. They don't have the same denominator. Remember, that's our life right now. Our life in fractions is, can I find the same denominator? So maybe you're good at this. Maybe you can ask yourself, well, does 3 go into 15? It does. I can just multiply it by 5. So this one could also be, I'll just write it in a different color, something over 15. Chantel? 5 over 15, because I multiplied this by 5 to get 15, 3 times 5. So I'm going to do the same thing. Guys, you're a little loud. So, now I have 1 over 15 here, and 5 over 15 here. How many over 15 do I have so far? 6. 1 and 5 is 6. How many more do I need? I need 9. Does that make sense? So now I can start to go in another direction right here. This one here, I have 6 and 5. How many more do I need to get to 15? Then I'll have 4 and 9. How many more do I need to get to 15? Then I can find this one, then I can find this one. Does that make sense a little bit? That's what you're looking for. If you're confused, again, we'll regroup at the back table in small groups and we'll work on that. All right, guys. Boys at the back. A couple people have asked me to see question 1, so we're going to work on question 1 and take it up. If you completely get it, it's okay if you guys keep moving ahead, but some of those other kids, they wanted to see this stuff again. So I want to make sure kids can find the common denominator, and then adjust the numerators so that they make sense. Shadi, all right?
She spit on me.
This is all, I'm totally all going on the website right now, tonight. She spit on me. I don't have a choice. Erg. Are you ready? What is question 1? Brooke?
7 over 10 plus 1 plus 6. 1 over
Sorry.
6.
7 over 10 plus 1 over 6?
Yeah.
So we need to find common denominators. Some people right away will be able to look at those, and because they're familiar with multiplication grids, we'll be able to tell that it's 30. Gentlemen at the back. So, some people will get that right away. If you don't, you can use one of two ways. You can use the multiples way, where you go 10, 20, 30, 40, 50, 6, 12, 18, 24, 30, and you see a match. And you'd use that as your new denominator.
You can
use 30 as the denominators, and that works out. But I must understand that the 30s come from these original fractions. And they have to become the new fraction that's equivalent with the 30 denominator. So, I have to ask myself now, what did I do to 10 to change the denominator to 30? Brooke? Times 3. And there's an easy way to tell. 1, 2, 3. That's how far over I had to move when I was counting multiples, yeah? Mm-hmm.
If the multiples, like with the multiples way and that way, does it always end up with the same denominator?
Will I always find a pair that matches? That's what you're asking?
Will it end up with the same denominator like at the end?
It won't always necessarily be the last number in my line. Because the issue with doing it this way, and the reason I've shown another way, is because you don't know how far you have to go before you're going to find two numbers that are the same. Like, I knew 30 because I knew that already. But someone who wasn't familiar with the numbers would have to write a whole bunch of numbers and hope they find a match soon. And some of the level 4 questions later, those matches are going to be hard to find and very hard to guess. So it's going to make this new way the efficient way to do it. But for now, you just find the first pair that matches. So I have 30 and 30. That's such a good question, by the way. So I multiplied it by 3. So I have to do the same thing to the numerator. What's 7 times 3?
21
21. 6. What did I do to the 6, Shahad?
times 5.
Times 5. And I could just count my multiples over. 1, 2, 3, 4, 5. I multiplied by 5.
5.
Times 5. Times 5. That gives me 5. So my next step, 21 plus 5 over 30. Once I write it that way, it seems a lot easier. And the reason I like to write it this way, guys, as my next step, is so that I don't end up doing something silly, like adding 30 plus 30. That's, again, the most common mistake, and I've made that clear in the chart papers in the room, is that people will go 21 over 30 plus 5 over 30 is 26 over 60. And that is not true. So this is a good next step. Brooke.
But what if, like, let's say you give that example on the test. What if someone completely forgets, and what if they mix up the line for dividing by 30?
It is dividing by 30.
Oh.
That's what a fraction actually means. That's, again, such a good point that some people forget, is that 21 over 30 is 21 divided by 30. It just so happens that when I divide 21 by 30, it won't be a whole number. It'll be some decimal number. It'll be less than 1. That's why we work with fractions. It's the numbers that are between whole numbers. Good question, though. So now, when I do that, 26 over 30. Now, so I have 7 over 10, and is it 1 over 6?
Yeah.
So I'm going to go like this. I'm going to write a 10 and a 6, and I'm going to start throwing prime numbers in there and seeing if they fit.
That was complicated.
It's worth trying one way or the other. So the first prime number is 2. So I put a 2 here. 2 times 10, or what goes in there is 5 times. 2 goes into 6 3 times. Now these are both prime numbers. 2 won't go into them, so I'll try 3. 3 does not go into 5, so I put a 5 here. 3 goes into 3 once. Now 2 won't go into 5. 3 won't go into 5, but 5 will. 5 goes into 5 one time. 5 does not go into 1, and the 1 comes back down. Here's why I use x's sometimes. When I'm looking at this, I know that my new denominator is going to be 2 times 3 times 5, which is 30. The same one we found on the other page. So that's not an issue. If you could just let me finish, and then we'll see if it answers your question. I know it's 30, so I have 7 over 10 is going to become something over 30, just like it was on the other page. 1 over 6 is going to become something over 30, just like it was on the other page. Sorry that looks like 36. So now I have to ask myself, what did I multiply by? Some of you will be able to tell right away. 10, 30, that's times 3. But some of you won't. And this tool works to help you with that. So when I'm changing my 10 to my 30, what do I need to multiply by? Find the x and move over. Times 3. That's what I'm going to have to do. And if there's more than one x, it'd be times 3 and times something else. But in this case, there's only the one x under 10, and it's beside it goes over to the 3, so that's what I have to multiply by. So if I'm terrible at this kind of multiplying in my head, I can still do this using this tool. So that's going to be a times 3 and a times 3. It's going to get me to 21. Same thing for the 6. What did I use? There's the x. I move over. 5. Times 5. Times 5. That's going to give me a 5. 21 plus 5 over 30. 26 over 30. So that's how you could use either tool to solve a question like that. More important than anything in the world, though, what is the first step?
Find the
Common denominator. Excellent.